So I'm going to do 26 and 29 for this next set. Still working on z-scores. This one is working backwards from the last. So on 26 to 28, we're going to use a z-score table, determine each percentile using a z-score table, and they're giving us information now about the problem. The heights of women are normally distributed with a mean of 64 inches and a standard deviation of 2.7 inches. So again, I just like to see this. I like to visualize it. So before I even look at the problems, I want to we've got a normal distribution, right? And by now this should be so common. Normal distribution means bell shape. A mean of 64 means that goes right in the middle. Standard deviation, I should go 3 up and 3 down. And I'm just going to use my calculator for that. We're getting into decimals. Let the calculator do the hard work. 6.4 plus 2.7 is 66.7. Plus another 2.7 is 69.4. Plus another 2.7 is 72.1. Go back down, right? 64 minus 2.7. I've got 61.3 minus 2.7. I've got 58.6. Minus that again, 55.9. Okay, so here I've got my normal distribution with all my standard deviations matched in. So I can kind of see what we're looking at. And we want to determine the 10th percentile for women's heights. So that means this is the 50th percentile, right? We know that 50% of the data falls beneath this. So 10th percentile would be down here somewhere. We want to figure out where does 10% of the data fall beneath. So what we need to do, we need to go backwards with our z-score table. Okay, so what we need to do is we need to look, up until now we've kind of been looking at the positive side a lot, but look at all this, right? Anything up here with positive z-scores, positive standard deviation is going to be more than 50%, right? So we need to come down here on the small side of things. Those negative standard deviations, right? How many standard deviations away will get us to 10%? So let's kind of look in here. 10% is like 0.10. So right in here, what's the closest? We got 0.0985. We got 0.1003. This one right here is the closest to 10%. So that's our z-score, closest to 10%. I mean, that's not our z-score, that's the percentile, right? And so we need to get the z-score from that. So that is negative 1.28, right? So that's the 100th place. Negative 1.28, so I'm going to write that down. So my z-score is negative 1.28. All right, now remember z-score is how many standard deviations away that is. So we really need to figure out, okay, well, that's how many standard deviations I went down. So what is that just in numbers, right? So in numbers, negative 1.28, if that's how many standard deviations I went down, but the standard deviation's 2.7, then if I multiply that, then that's just how many numbers I went down. So this times 2.7, my standard deviation, equals how many numbers I went down. I went down by negative 3.456 from the mean. So now I just need to go down that far. 64 minus 3.456, and that is 60.54, and I'll just stop there. So really, this is all rounded to the nearest tenth, so we'll just say 60.5. So 60.5, right around here, this is about the 10th percentile, right here at 60.5. All right. Okay, you do 27 and 28 on your own. And now let's look at 29 through 31. This is a comparison problem. So saving the hardest for the last, we've got to use the following information. Grange dishwashers have a mean life expectancy of 10.5 years with a standard deviation of 0.9 years. And Sparkle dishwashers have a mean life expectancy of 11 years with a standard deviation of 1.3. Okay, so they didn't tell us they were normal distributions, but we're gonna just assume that they are. And again, I prefer to draw them out. So we got Grange, right? Grange, normal, 10.5. And we've got Sparkle, normal, with 11, right? Okay, now Sparkle goes up by 1.3, so this is 12.3, this is 13.6, 14.9, right? Go down, I'm gonna let the calculator do the harder work. 11 minus 1.3 is 9.7, minus 1.3 is 8.4, minus 1.3 is 7.1, right? But that's for Sparkle with a standard deviation of 1.3. Okay, Grange has 10.5 going up by 0.9, right, for the standard deviation. So 10.5 plus 0.9 is 11.4. Is 12.3, going up to the third one, 13.2, and then going down, 9.6, 8.7, and 7.8. So hopefully this is getting old hat by now, right? Drawing the normal curve, putting the mean in the middle, going up by 3 standard deviations, down by 3. Up by 3, down by 3, right? Okay. Now, the first question says, determine the dishwasher that is more likely to last less than 9 years. Okay, so first thing we need to figure out is how likely are these to last less than 9 years? And how likely are these to last less than 9 years? Somewhere in here, right? So we're needing to figure this out. It doesn't land on a standard deviation, so that means we're stuck with z-scores, right? So that means we just have to figure out how many standard deviations is 9 away from 10.5. How many standard deviations is 9 away from 11? So we'll do it for both, okay? So 9 away from 10.5, right? So 10.5 minus 9 equals 1.5, but that's how far away it is. How many standard deviations away it is depends on what the standard deviation is. And for Grange, that's 0.9. So we divide by 0.9, right? So 1.5 divided by 0.9 is 1.6. And remember with z-scores, we round to the nearest hundredths. So that's 1.67. That's the z-score for Grange. So we'll go get that table. This is the negative side. Look for the positive. We go down to 1.6. And then over, you can barely see it, but 1.61, 2, 0, 1, 2, 3, 4, 5, 6, 7, right? So, I went backwards. So that should be negative. I should not have subtracted. So, mistake corrected, right? Because does that make sense? So, good. I told you guys I make mistakes. Now you're watching me do it. I went to 1.67 on the positive, right? And that's telling me 95% of them fall. But I know that can't be true. I know that can't be 95%. So where did I make my mistake? I subtracted and called it positive. This should have been 9 minus 10.5. So my mistake, that should be negative, that should be negative. Easy fix, right? Just find the correction. So I'm glad I got to model that for you. So now I need to find negative 1.67. So negative 1.67, we'll just count over. Here's negative 1.6 and then 0, 1, 2, 3, 4, 5, 6, 7, right? Oh, but again, I made another mistake because it's backwards, right? Okay, so really, negative 0.7 all the way down here, right? So really it counts backwards this way, right? 0, 1, 2, 3, 4, 5, 6, 7. So here, 4.75%. 4.75%. So for Grange, 4.75% fall below. Now, with Sparkle, we want to know how many fall below, so we do the whole thing over again. So this time we're going to do it right. So all those mistakes we made last time, we get a chance to correct them this time. That's the great thing about mistakes. So this time I'm careful. I know I need to do 9 minus 11, right? And I need to, that's how many numbers away, and then to figure out how many standard deviations away, I divide by 1.3, okay? So 9 minus 11 divided by 1.3, 1.54, rounding to the nearest hundredth, negative 1.54, right? So that's my z-score. That's how many standard deviations 9 is away. Now I go to my chart, negative 1.5. Now remember, we're counting backwards from over here, right? We start with the 0 over here, negative 1.5, 0, 1, 2, 3, 4. So here, 6.18. So 6.18% fall below 9 here. Okay, so we did all those calculations. Now let's make sense of it. Let's actually make real world sense of that. So Grange dishwashers, for 4.75% of Grange dishwashers last 9 years or less, right? Less than 9 years. 6.18% of Sparkle dishwashers last less than 9 years. So which is more likely to last less than 9 years? Sparkle. Sparkle is more likely to last less than 9 years. Okay, you do number 30 and 31.